Hey, this is Passy from Passy's World of ICT, the guy with the white hat. And yeah, some girl, I assume it was a girl, emailed me this week and said, oh, why do you wear a white hat? Are you bald? No, I'm not bald, I've got hair, but the thing is it's Saturday morning and I just got up and like my hair's really messy, so put on the white hat, and that's my YouTube trademark as well. And a shout out to those guys that emailed me from, I don't know, somewhere in Victoria. They're doing Year 12 VC software development and said, thanks for the videos that they're helping them out and they're finding them really good. Just one thing on emails, I cannot answer your questions or check your program code for you. I'm very busy with a day job teaching at a high school where I've got like over 50 students doing software development. So I'm full on with that and making the YouTube videos and running a photography business on the side. So let's get on to what we're doing today. Anyway, this is kind of validation part 2. We're going to get into something a bit more technical, but it's nice and powerful and it's good too. We're going to use ASCII codes for characters that are being typed on the keyboard. And we're going to use this Visual Basic regular expressions, Regex is-match processing as well, to sort of do some validations that are ones we haven't done before, but ones which you will need to be able to do on your software projects. And so let's get into it. Okay, so this is, as we said, this is kind of like validation part 2, this lesson. And what we're doing in this one is, we're looking at some specialized methods. So we're going to be checking ASCII code values of individual characters that people type in to see whether, you know, if it's a number field, if they're actually typing numbers in and not doing any letters or commas or other things or spaces. And also we can do pattern matching as well, which is really handy for checking phone numbers that have dashes or hyphens in them, and email addresses as well that need to have @ signs and dots in them. All right, so I've already learned a lot about validation in that first lesson, but this is kind of like a new specialized validation techniques lesson which adds on to that. You don't have to have watched the previous validation lesson, but you know, it'd be good if you have been doing our course in order and have got some knowledge before you come in and do this lesson straight away. If you only want to know how to do one sort of validation, like doing an email, what you could do is you could just go to the YouTube description on this video, go to the index, and there'll be a timeline index, and you can find out where we do email validation and just click straight to that section of the video and watch the 2 or 3 minutes on that, all right? But anyway, let's get going here. So this validation that we're showing here, this is what's happening here is that on this customer ID we're doing, it needs to have 8 letters here and then 3 numbers on the end, so 3 digits on the end. So it's 11 characters long altogether. And you can see the problem is here, they've put a number in the middle of the thing. They should have only had 3 numbers on the end. So with this ASCII code validation, we're able to pick that up no matter what digit it is, what letters it is. Using the ASCII codes, we can do that and give them a message. And then in the third part of the video, near the final part of the lesson, and warning, this is going to be a long lesson, we'll do the regex pattern matching, the regular expressions. Now, that is really good for email addresses. So you can see on this email address on the right hand side here, they've left out the @ sign, and so we can detect that with regex pattern matching. And what will happen is we can give them a message then. The address should be like something with an @ sign, something, then dot something on the end of it, okay? So this is validation for sort of more specialized things like product codes, customer IDs, people's names, email addresses, and phone numbers is what we're looking at in this lesson. All right, now just a warning, this lesson will introduce what looks at first like really super long and complicated code. But you need to kind of learn this and understand what it's doing. Don't memorize it, because usually when you do your assignments or if you're doing programming, you know, you've got previous things to look at, like, you know, the PDF from this lesson or something like that. You can scroll through, or you can go to Stack Overflow and Google and do all these things. So you don't have to actually memorize the coding, but you need to understand what it is and why we're doing it and how you do it in certain situations. Now, don't be scared off. It will be complicated. So we're going to do string processing as well and substring processing and ASCII code values. That's all new stuff. And look, I know when you're getting a whole bunch of new stuff to learn, it can be really hard. And first time I saw this when I was first learning the program, I thought, oh my goodness, this is just another world of complication. But look, after a while, it gets easier and you just have to do it a few times and practice. And you might have to watch this video more than once in some sections to get the gist of what's going on. Okay, so string validation for text boxes. Now we're going to be talking about these things called strings. Now what is a string? All right, now a string is just a group of characters that's been typed into a text box. We'll just consider it as that for this lesson. And you know, when they type things into a text box, they could type letters of the alphabet, they could type numbers, they could even put commas or full stops or @ signs and things like that. So it's just any character off the keyboard which they happen to have typed into a text box. And that includes using the backspace key for rubbing out mistakes as well as pressing the enter key too. Just be aware of that. And so a string, like everyone kind of knows what a string of Christmas tree lights is, all right? That's a photo we did for the Photos by Passy Christmas card a couple of years ago, I think. But anyway, we've got a string of lights there. So you've got individual lights that are connected together to make a whole string of lights. So when we have words in sentences, all we've really got is just individual letters of the words all connected up in a string, in a line, if you like, connected to each other to make a word. So that's what a string is. So when we're talking about Christmas, we've got something like lights, and that's a string. If you count up how many letters in it, it's got 1, 2, 3, 4, 5, 6 letters. So that has a string length of 6 characters, all right? So that's a string. A bauble, those round balls that hang on the Christmas tree, if we count up the letters there, that also has a string length of 6 characters. And tinsel, that kind of shiny, glittery stuff you hang all around the tree, that's got a string length of 6 as well. But hang on, we've got a little problem here. We've got the number 666, which is a devil's number. And Christmas is all about Christ's birthday. So what's the hell is going on with the devil there? Oh, thank goodness we've got ornament. Ornament has a string length of 8 characters because it's got 8 letters. So that's the basic idea of a string. And in our program coding, we'll have like a text box. So we might have a text box, text Xmas decoration. So text for Christmas decoration. And the property we're looking at, that's the name of the text box. The property of what's in the text is the .text property. So if we want to reference what's in there, you know, you put the text box name .text. So you've seen that in other programs we've done. Now what we usually do is we take the contents of that text box and we move it into our own program variable. So we'll set up our own string variable inside the program that's going to be string Christmas decoration. Then if you want to know how long it is, like how many characters are in that string, you can just put a .length on the end of the name of that variable that's in your program. And that's how we find out how long strings are. And that's going to be important to be able to know how long a string is before we actually start checking it. So some of the string validations we're going to do in this lesson, we're going to do surnames in text boxes because they need to contain just letters, hyphens, and spaces. All right, you don't have @ signs or dots in the middle of them. And a phone number. So phone numbers are often formatted, you know, with some hyphen sort of things in between to make it easier to read, like 04-123-5678. So we're going to learn how to have it in that format, but then how to check that everything's okay. And in that 1, 2, 3rd position there is where we should have the kind of minus sign hyphen. So you can actually pick out that position using substrings, all right? So the Visual Basic code would be that we've got the string phone number, but if we go down inside the string phone number, we can go .substring, and the 3 means go to position 3. So we'd be going 04, position 3 is where the dash is, and we could check, okay, position 3 there on anything they've typed in, that needs to be a minus, a dash sign. Okay, so we use substrings as well, little groupings inside the number to check exactly what's in that position, because that position 3, it's supposed to have a dash. Okay, because that's the way we're formatting it there. And we're going to go into detail in that in the lesson. So a certain customer ID, we've got a customer ID here. It has to have 8 letters or spaces and then 3 digits on the end, a 3-digit number on the end. So something like H Simpson, 1, 2, 3, 4, 5, 6, 7, 8, 8 letters, and then we've got 142, 3 digits on the end. Or if someone's got a smaller name, it's padded out or filled in with spaces. So you've got like Joe Zoo, who's only 5 letters. So in here we put 1, 2, 3 spaces to bring it up to 8. And then on the end you have the last 3 characters. So we'll be doing that, learning how to do that. And email addresses, so something like passy@yahoo.com, julia@bigpond.com.au. We can check that it's got the @ sign in it, that it's got a dot something on the end of it, and so we can check that it's the right sort of format. So we're going to be doing validation for all those sorts of things, and it is going to be a long lesson, but remember, just use the index that's like in the description for the video, because then you can just go and watch the section that you need to watch. All right, so string validation using ASCII codes. What are ASCII codes? Okay, we're going to start by using these ASCII codes. So every keyboard character that we can type on our keyboard actually has a ASCII code value. So when you type, for example, up here, a capital A, an uppercase A, we're going to use the the decimal ones. The decimal value of that is 65. So if we want to check if someone's typed the letter A, we can check that character in our program. Is the ASCII value of that character 65? Is that what it equals to? Now, people might be thinking, yeah, well, that's kind of really crazy. So we'll get to that in a minute. Our person's last name, we need to have it uppercase letters, right? So we want to just have it typed in big letters. And so big letters, sorry, and lower letters. So I only want letters in the name. So what we can do is we want to have, if we're checking any letter within a person's name, just one position along that string of letters that make up their name, we want to check that it's either a big letter, an uppercase one, or a little one, or some people like Watson Smythe and Jean-Claude Van Damme might have a space or a hyphen in their name. So you also have to allow spaces and hyphens, which is number 32 and 45. Now, if you were going to code this and not do ASCII codes at all, you could just say, okay, we're at the first letter in the name, and we know it needs to be a capital letter. So we could say, if that equals capital A, else if it equals B, else if C, else if it equals D, else if the letter equals E. Now that's going to get really long. We're going to have 26, kind of if statements, which is going to be a horrendously long piece of code. Now you can do it a lot quicker with these ASCII code numbers, because what you can check is if the number is between 65 and 90, so when you convert the ASCII code of that particular substring position or that letter, if that number comes out greater than or equal to 65 and less than or equal to 90, well then you know you've got one of these capital letters. So 26 lines of individual checking code there will reduce to 1 line in Visual Basic and in other programming languages as well. So ASCII codes are used, like you can use them in Python, Java, C++. All languages have access to ASCII codes. So we're kind of teaching you first principles things here, which you'll be able to take on to later languages which you learn. Okay, so we also need to consider when they're typing in a text box to also allow backspace and carriage return, or the enter key, because someone might make a typing mistake and we don't want to stop them from being able to press the backspace key to rub it out and redo it. And a lot of people like pressing enter after they've finished putting something in, because maybe they're used to using Microsoft Excel and just pressing enter after they've entered values into a cell. So you've got to allow that to happen as well. So we also need to include numbers 8 and 13. So these are the groups of numbers which are going to be okay. Like if they've done any of this while they're typing in a name, that's fantastic. We know it's good. If it's any of those other numbers though, we know it's bad, because we don't want numerical digits or semicolons or equal signs in the middle of someone's name. All right, so we can also immediately check a letter using a thing called the key press. All right, so this is kind of the first part of our lesson now, using key press and ASCII codes. Then the second part of the lesson will be looking at a whole text box that's already been filled up and checking the letters with substrings. And the third part will be using the regular expressions, regex, pattern checking. So there's 3 parts of this lesson. Okie dokie. So the first technique is key press, all right? So when they press a key, we can check the key straight away, and if it's not the right sort of key, like if they're trying to type a number into someone's name, we can just say, nope, we're not gonna let you do that, and give them a message box. So let's set this up. So you need to make a new Visual Basic project and just get a form started up, have a label here, person last name, have a text box in here where they can type in their last name and call that TXT last name using the Hungarian camel case notation there. So get that all set up with a new Visual Studio Visual Basic project. And what we're going to be doing is we're going to be looking at the key press event. So as soon as they press the key, we're going to check, is the key between 65 and 90 when we get its ASCII value, or when we get the ASCII value of that key, is it between 97 and 122, because that's all good, they're letters. And also we're going to allow hyphen 45 and space, which is ASCII number 32, and also the backspace key so they can delete stuff, though that's ASCII 8 and 13. So all of these numbers listed here are good numbers. So if they do that, that's good. But if we get any other sort of numbers when we work out what the ASCII value is of what they've pressed on the keyboard, well, then that's going to be bad, and we're going to give them an error message about it. All right, so it's best you do this and follow along with the video and pause as you need to. So get that form and text box set up and then come back to the video. All right, so you double click that text box you got on the form and that generates some default code for you. So you double click on your form, takes you into the code writer, and it'll make this private sub here that's for text change. So if the text in that text box gets altered at all, it's going to do whatever code you put in this gap here. Now we don't actually want to use the changed event, we want to use the key press event. So what you can do is in this code editor up here, it'll have a lightning bolt for events, and you click on this little arrow here. So let's color it in so you can see it better. So on the lightning events here, you just go over to where there's that down arrow and click the down arrow, and we need key press. So we're not going to use the default text change that happens when you double click on a form. We're going to use key press. So you click onto that key press event, and what will happen then is you'll still have your default text changed one, but you'll also now have the key press one. So what we need to do is we need to delete this one out. So just delete all of that, the private sub and the end sub, delete those lines of code, but keep these ones that are circled down here. So we want to keep the key press code, all right? So that's how you do that. Now, someone might think, well, could you just change the words text changed in there to key press, because that seems to be the only thing changing in that code. Look, I'm not sure about that. I researched on the internet and watched some things, some other videos, and this seemed to be how everyone does it. So I'm assuming this is the way you do it, where you have to actually click that, select key press, then you've got two of them, get rid of the one you don't want, keep the key press one. So I'd suggest doing it like that, because I know that way definitely works for sure. All right, in the key press subroutine, we're going to add some ASCII value code checking now. But we also need to, just up the top of the program, straight under public class form 1, make sure you dimension this variable so it's a public variable. So we need to put dim boolean last name valid and just set that to false. So we're going to have this sort of boolean true false indicator up here, and you need to just put that straight under form 1. Then you go down into your code where it's got the key press subroutine, which we just put in, and inside that subroutine, you're going to have this coding. So we're going to check if the ASCII code is between 65 and 90, that's good. We know it's an uppercase letter. If it's between 97 and 122, we know that is a lowercase letter. And we also have to do 45, 32, 13, 18, because that's for hyphen, space bar, backspace, and the enter carriage return, the enter key. Okay, so they're going to be all the good ones. And if we get them pressing one of the good keys on the key press event, that's great. We'll say the last name valid is true at the moment. But if they've pressed a number or an @ sign or a comma or the print screen button or something like that, then we're going to say message box, put up on the message, type in letters only and tell them they've got an input error. Okay, so that's the way that code is going to work. And this e.handled, what the heck is that all about? So if they have not typed it in correctly, we're going to use this e.handle. Now what e.handle does is it tells the program, it tells Visual Basic that usually on the key press, Visual Basic would handle the event or process the event. And when you press, say, the letter P, it handles that and puts a P on the screen in the text box. So if I press a dud letter like the number 5, it's going to put that 5 up onto the screen in the text box after it gives the error message, which kind of doesn't look good. So what you do is if you put e.handle true in the code, it tells Visual Basic, hey, don't you handle that thing because we're going to do it ourselves here in the code. So what will happen is that the code's going to be handling it, so it won't appear in the text box. So it's best not to let bad things into the text box at all, okay? So we don't want to show them the 5, the silly thing they typed in. We just want to, as soon as they hit the number 5 on the keyboard, tell them that, no, you can't do that, and not let it be in the text box. So we put the e.handled equals true in there. Just when you make this little program to test it out, because you should be like taking this now and testing it, yeah, try take the e.handled out and see what happens, and you'll see what we're talking about here. So if we use the green arrow to run and test this, what's happened here is we've started typing in letters and that's all happy, but if we're at this position, and like you type in a number or you type an @ sign or a $sign or something like that, well then straight away this message box will come up, and when you click OK, it's not going to show the $sign or @ here because we use that e.handled, okay? So that's how it works, and you should pause the video now, have that code in there, and you should try this out and make sure it's working okay. That if you do letters, it's fine, but as soon as you press other characters on the keyboard, it's just not going to even put the characters in the text box. It's just going to stop you straight away with a message box. So pause the video and make sure that is working. Okay, now some people don't like having that message box because when it pops up, people have to they have to press the OK button to get back and fix it up again. Some people like this tooltip, which is kind of like a little message that fades onto the screen. So we're going to use tooltip now and show you how to do that. All right, so to do that, we're going to make another field, another text box, and this is going to be for putting the person's first name in. So you can just like go in these two here. If you hold down Shift, you can click on both of them, do your Control-C, Control-V stuff to make a copy of them, and then just rename the label person or first name. And this text box here, just make sure it's called TXT first name on the form. So pause the video, do that on your project, go into your form, add another text box, TXT first name onto there. Now the tooltip, how that works is, I thought that like you'd take this tooltip out of the toolbox and you drag that onto this text box because that's where you want the tooltip to appear, but that's not how it works. The way it works is you just take the tooltip and drag it out onto any empty part of the form around here and put it on a blank part. And what will happen then is that it'll appear down the bottom here underneath your form. It'll tell you that you've got tooltip functionality available, because we can actually use the tooltip on any of these text boxes or anything on our form. It's not limited to one item. It's kind of a generic general tool you can use on anything at the moment. So we just have this down here. Now in its properties, when you click on it where it's down here, just make sure you call its name tip valid data, like was spelt down the bottom corner here of the video, right hand corner, tip valid data. That needs to be its name because that's how we're going to reference it in the program code. All right, so pause the video if you need to and get all that set up on your form. And then you need this program code here. So basically for the first name, you can pretty much copy and paste the same code you use for the last name because it's all the same things. We want letters or hyphen spaces, backspace, and enter keys. So you can just copy and paste that, but make sure you've got Boolean first name, not last name here, Boolean first name valid. So you'll have to dimension that variable up the top of the program as well. And when it's wrong, instead of doing a message box, you just use tip valid data. Remember, that was the name of our tooltip that we named it in the properties. And we want to make that guy show up. And the tooltip we want to say is type in letters only. And then we've got some other code here as well. So how that works is that if we're typing in the first person's name like PET, and that's all going okay, but then we press a comma on the keyboard, as soon as we press the comma, this tooltip here will kind of fade in. And we'll jump across to the program because we'll kind of just show you where we're up to now. So this is where we're building that program, and we'll just give this guy a little run out of the executable binary file here. So here we go. Here's what we've got. Oh, also, we're going to do a third one in a little while too. But for the person's last name, like if we're typing in Passy or whatever, that's all working fine. I typed the number 5 there, so it said type in letters only. And if I put a comma, it's going to stop me and do that as well. Now for the first name, when I put that in, so here I'm just going to put a comma, and see, it won't let me put it in, and it puts up this tooltip, type in letters only, and then the tooltip fades away. And like if I press the number 7 now, it'll just do the tooltip. And if I do shift with a question mark, it'll do the tooltip. So until I do a letter like this, then the tooltip will stop and it's okay. So it's just kind of nicer because what it means is that when you type things that are incorrect, it's not going to put them in, and it'll just put the tooltip up, and the tooltip kind of fades away itself straight away. You don't have to kind of move the mouse and click a message box or anything like that. So yeah, a lot of people prefer that than having message boxes. All right, so that was just to show you that. And let's go back now to the presentation, which is happening here. Now, what were those parameters, these other things on the tooltip? That was the message we were seeing, type in letters only. The sender, now what the sender does is the sender puts the tip into the text box, which at the moment has the focus. So the active text box, which has focus, and you would have learned about that in our previous validation lesson, is this one here. So because it's active at the moment in that one, this is the sender one. This is the one that's sent the problem and said, hey, there's something wrong here, bring up a tooltip. It knows to put the tooltip in there, okay? If we were typing in here and we'd done this one with a tooltip, it would know to put the tooltip into that box. So the tooltip is just one thing which you can use on the form. And for different things, when it's in different places on the form and you want to use it by putting this data, the name of the tooltip and show, you can have different messages in here as well. Now the 2000, that kind of is a number which determines how long that stays on the screen for. Perhaps mine was a little bit long, I'm not sure. You could change this and make it longer or shorter with that number. So that's what those things do. So anyway, that's tooltip. So that's something else that you can know about and is handy in your programming. And remember, like if you come back later on, you're thinking, yeah, I think in that validation video they did something about tooltips. You can go to the YouTube description, go to that timeline index, find tooltip, click on that, and this will show you this part of the video and you'll know how to do it. So let's look at validating some numbers now using ASCII code. So we're going to add a third text box, which we just saw a minute ago. This one, number of pets, okay? So you could just like copy this label here, Control-C, Control-V, change it to number of pets. Copy the text box, Control-C, Control-V, change that text box to text number of pets and just grab the end of it and shrink it down a bit. And how we check this with ASCII codes and key press is that when we look at our ASCII values, for numbers, if we want to check if it's a digit like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, you just need to use the numbers 48 through 57, okay? So what we can do is we can check if it's less than 48, any of these characters, they're all bad. They're not numbers. We don't want them. And if it's greater than 57, we don't want any of them either because they're not numbers. So you can do your validation by saying if whatever's typed into that text box after you've put it into your program variable, if that is less than 48 or it's greater than 57, well then that's bad, and put out an error message on that. Okay, so the coding you put in is sort of that If it's in the range 48 to 57, or it's a backspace key or an enter key, because they might just be typing it to fix it up if they've made a mistake, well then it's okay, that's all good. Otherwise, put out the message, and it's going to be a tooltip message that type in whole numbers only, okay? So this is a way of getting whole numbers. So if we jump back to where that program's running, if I can find that here. All right, so with that number of pets, like if you type in a whole number, that's fine. If you try and type the letter G, it gives you that tooltip. Try and type the letter P, it says type in whole numbers only. But if you're putting in, if you want to put in say 1.5, because hey, we've got a dog, plus we've got a little puppy, which is really small. He's so small, he's kind of like half a dog. So they want to do 1.5. As soon as they do the dot, it's not going to let them type in any decimal values, and they can't do a fraction. So I've only got a puppy, so it's like half a dog. So we'll do one kind of slash 1/2. As soon as you hit the slash key, it says type in whole numbers only. So this is a great validation for ensuring that they only put integer whole numbers in by using that tooltip and key press. Now on the checking, you could also check that the keyboard character they've typed, instead of having if it's between 48 and 57, you could also use if it's numeric. You could use the isNumeric function. And some people might think, oh, well, Passy, that's so much easier. All we do is put isNumeric, and isNumeric makes heaps more sense than this ASCII.keychar and some number that we don't even know what that number is. Yeah, the thing is, this is a built-in function for Visual Basic that works great in Visual Basic and is quick and easy. But if you're swapping then to other programming languages, like you decide you're going to want to learn C++ or Java or Python or something like that, it does have ASCII character processing, but it doesn't have this isNumeric. So you kind of have to do it this first principles, old school kind of long way. So this is the best way to learn how to do things, because this will lead you into other programming languages. All right, and as we showed you, if they try and do a dot to put decimals in, you know, it's going to stop them straight away. So they'll only be able to put in the digits 0 to 9, which will limit them to whole numbers, or they could put a 0 in because maybe those people don't have any pets at the moment. Okay, now that finishes key press events. So key press events are really handy. So that's part 1 of the video finished. So this is going to be really long. So maybe you just want to pause and take a break right now and then come back to the video. So do that. All right, let's look at whole string ASCII codes validation. Okay, so this is a new section that we're doing here for the video. So in this one, we're going to wait until the user has filled up the text box with all of the required data, like for a customer ID code, and they've clicked on an update button. Then we're going to validate it. So we're not going to do key press character by character checking. On this one, we're just going to wait till we put the whole lot in, press the update button, and then we'll check the whole lot. All right, so we're having this 11 character customer ID for this example. So it needs to be 8 letters or spaces and then have 3 number digits on the end. So a valid or a good customer one that's okay is like H Simpson, because that's got 8 letters. Then we've got 001, so it's got 3 digits on the end. Now, if you've got a shorter name, like you don't have exactly 8, you just put like Joe Zoo, he's only got 5, so we put in the 5 letters. Then you have 3 spaces in here to fill that up to 8 before you put 001, the digits on the end. Okay, so we might be filling in the spaces. What if someone has a really super long name? Well, you only type the first part until you're up to here, and then you just leave the rest of their name off. Okay, hopefully that will be enough combined with a number to be a unique identifier, which is what you need for a database key if you've done our databases course. But anyway, customer IDs need to be unique. So we're going to be checking character positions in this. So we need to check that they've got kind of letters or spaces in these positions, and then on the end they've got some number digits. All right. Now this is going to be a little bit painful, because you notice here H, well, that's the first character in this customer ID, H Simpson 001. So why haven't we called it position 1? That's in the first position. That's the first damn character in there. Well, Visual Basic, and not just Visual Basic, but a lot of other languages, they like to start their numbering at 0 instead of at 1. And I think if you watched our algorithms lesson previously, we spoke about this with loops, that often loops start at 0 and they don't start at 1, which can be really hard for beginners, all right? So it's actually the numbering, the position, that's position 0. These are positions 1 to 7 that have to then be letters or spaces. So we've got to have a capital letter to start off with, all right? That's non-negotiable. That's the only thing that's allowable in there. After that, you might run out of letters because I've only got a short name. So you can fill the rest up with spaces. That's okay. So these are letters or spaces in 1 to 7, those positions. And positions 8, 9, and 10 have to be number digits like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so these are number digits on the end. All right, now this is another problem too. Because you start at 0 and you're ending at 10, you think, oh, that's 10 long. There's 10 characters on there. Well, actually, it's 11 characters because we started at 0. So if we were writing a loop to go all the way through here, it's going to be for starting at 0 and ending at the length of the thing's 11. 11 minus 1 is 10. So that's something else to be aware of as well. All very complicated, I know, and you're probably starting to really hate this. But position 0 has got to be an uppercase letter. How we can pick out that position to check it with Visual Basic Code is this thing's going to be called string customer ID, the whole thing there. And we're going to have to do substringing. So we only want to get this part that's circled here. And that substringing, how you specify that we just want this little bit that's only 1 character long, is first you put where that one little bit is. Well, it's at position 0, so we put a 0 in here. That's its position. Then comma, this is how long it is, how long you want to go. So we want to be at position 0, but we only want to go for 1 character, so we only want this. So substring 01 will just get that character, and we can check out if this is okay or not. Now, in the next part here, we've got positions 1 to 7. So to substring that, if you want to check all those at once, you just say, well, string customer ID is that whole blue box there. But we just want this purple bit here, 1 to 7. So you say substring starting at position 1 for a length of 7. So we want 1, 2, 3, 4, 5, 6, 7 of them. So that's how you substring out and get just that bit there, okay? And this last little part here with the 3 digits, that's another subdivision of our big string or a substring. And that one there you would do by substring 8, because we're starting at position 8, and we're only going 1, 2, 3, a length of 3. So substring 8, 3 would pull out this bit here that's in blue to give you the 0, 0, 1. So with the substring processing, we can kind of pull strings apart and divide them up because we want to work on this in the validation in different sections. We're going to have one section that checks this first one. Have they got an uppercase letter in there? Another section that will check this bit of stuff. Have they got letters or spaces? And then a final section in the validation that's going to check out these last 3 digits at positions 8, 9, and 10. Check out that they're kind of number digits between 0 and 9. All right, now looking at that whole slide, that looks immensely complicated, and you're probably thinking, that's it, I'm quitting programming right now. Well, look, you got to think about anything. Like I remember when I was a little kid and I'd gone to America to live and I was learning how to play basketball, okay, for the first time. And look, bouncing the ball was okay, and like taking some shots, standing, that was kind of okay. That was easy to learn and that. But then I just kind of got okay at shots, but then I had to learn how to do a layup, which was like this totally different thing. You got to kind of go storming into the basket, kind of jump up with one hand and sort of lay it up and get it to bounce off the backboard. And man, the first time I tried that, that was so complicated. And I thought, I was so happy just bouncing the ball and shooting it into a basket. But now I've got to learn how to run up and kind of turn sideways and twist around and bounce it off the backboard. And I thought that was the hardest thing, you know. But then after I learned to do it, it was like really easy. And it's just like, do I take a shot or do I run in and do a layup? And it was just so easy and it was natural. And it's the same with this coding. Like the first time you start something like this with substrings and positions and pulling out little bits with numbers with commas, and then there's these ASCII code number values, so we don't say the letter A, we say 62 or something like that. It's all just really crazy stuff, like learning to do a layup in basketball. And look, I'm expecting that you guys will be finding this really hard. And look, don't be surprised if you are. That is completely natural, and that will happen when you're first learning a program. So you might have to kind of look at this slide for a while, study it a few times, go through the video, kind of work it out. But look, once you learn how to do it, you'll be fine. But it will take some work learning how to do it, okay? And just be aware of that. And don't feel bad if you're having troubles that, hey, I'm the real dumb guy in this group because I can't work this out. No, it's not. A lot of people are dumb guys. I was a dumb guy when I started too, believe me. All right, so let's get on with it here. So we're going to set up a new VB project. So save that other project you did, close it down, start a brand new one. We're making a form here that's got a text box where we're going to be able to enter that 11 character customer ID code. So we're calling that TXT customer ID, that's the name of that text box, and this update button that's called BTN update. So this isn't something you create on your form, this black and white box here. This is just telling you call that text customer ID and call that BTN update, all right? So just pause the video and get that made quickly in a brand new project. All right, then we can start the coding. So the first thing we need to do is double click on that update button that you've got on your form. That'll take you in there for the event when the update button is clicked. So we're just going to use program modularization like we did in validation part 1 lesson. So we're going to, when that button's clicked, we're going to jump off to a separate subroutine that's just going to be for validating customer ID code. Because the reason is we're going to add phone number and email on here later on as well. And we don't want to end up with just this massive slab of code that's doing all 3 of those text boxes. So we're going to isolate each one separately. So this is just going to be code that validates the customer ID text box. So we need to just set that up. On button update, that's all we do. We're using modularization, so just putting the name of the submodule we're going to have in there at the moment with some brackets on the end. Then we're going to actually write a separate subroutine underneath, which is called validate customer ID brackets, same name. And this is where we're doing the work. So first we're going to dimension our own program variable string customer ID, and we're going to move what was in the text box off the screen here that they've entered. We're going to move that into our own variable. Then we can start substringing this and pulling it to bits and checking out how it's looking. So what we're going to do is we're just going to look at the very first position in there, what the first thing they typed into that text box. So we're looking at position 0. So we're going into the string of the customer ID, we're grabbing a substring, we're just grabbing part of it, and the part of it we want is that very first position at 0, and we just want a length of 1, so we just want that very first character. If we wanted the first 2 characters, you'd put a 2 in here instead of a 1. If you wanted to grab 5 characters, the first 5 things they typed in, you'd put comma 5 here. Now, if that first character is smaller than 65, or it's bigger than 90, well then it's not one of the uppercase letters, because uppercase letters are between 65 and 90. So if you're outside that range, well then that's not good. So we're going to put up a message, first character must be an uppercase letter, and have that message box have input error up the top of it. But if it's all good, we're going to say update successful, customer ID updated. All right, so we build a subroutine that's going to do the validation. So pause the video now, you should have your form. Double click on the update button, put this into the update button subroutine. That's all you do. We're just doing a call, 1 line of code here, which is then going to go off to this bit, which you're putting underneath there in your program, and that's going to do all the work. And check out that that is working okay. All right, now we can also make life a bit easier by setting character casing property on that text box so that anything they type in is automatically converted into uppercase big letters, all right? How you do that is you just go on the text customer ID, so on that text box where they're putting the customer ID in, go to this property called character casing, and it's usually set to normal. Just put it onto upper. So get it set onto upper. And what will happen then is, like if you just type little letters in here, it doesn't matter. Visual Basic will just turn them into uppercase letters. And that's great. That doesn't mean we have to check for little letters and then convert them into big letters or anything horrible like that. Visual Basic has kind of written that little subroutine for us, and it's a built-in function. So make sure you do that. That way everything they type in will be in big letters, and that'll be all good. And another thing you can also do with properties is, there's another property on the text customer ID box where the max length of it, the maximum length of characters they can type in, and it's absolutely huge. It's like 2 to the power of something because it's binary. We don't need to type in 32,000 characters for a customer ID. In fact, we only want to type in 11. So we need to drop this down and make sure that's set to 11. So the maximum length is 11. And that kind of takes care of a validation for us. That's going to check that they don't put in a customer ID that's bigger than 11 characters. So this is kind of like saving us work by setting this property. Now, if you really like coding, you don't have to do it in the properties box on the form. You can actually do it in the program code. So if you double click anywhere on the form, you'll find that in the code, it brings up this subroutine called form1load. If you double click in any of the blank parts of the form, and in that load subroutine we can just set up that the text customer ID dot max length, that equals 11, and the text customer ID character casing, you can't just put upper, you have to put character casing dot upper. But anyway, that'll force them all to be uppercase and make sure they can't type more than 11 characters into that box. So, you know, in other languages, you would do it probably in the code, but in Visual Basic, we have these nice little properties on forms and stuff, and we can kind of do it that way. So either way, it's okay. You can even put both things in to be sure, and it doesn't cause any problems. All right, so when we tested that, we got some crashing problems. If the text box contains blanks. So we were testing this code. We didn't take print screens here, which we should have done to put in the presentation. But yeah, we were testing it and it was all looking good. It was finding out whether that first character was a letter or not. But what would happen is if you had the Homer Simpson guy, remember we did Homer Simpson testing in our previous video, good old Homer might just leave that blank completely and go straight down to the update button and click it. And if that happens, you get a program crash straight away, an exception, and everything stops in a screaming heap, a car wreck. Now, the reason that happens is that if this text box is completely empty, see in this code here, you're asking it, can you go along in what they've typed in and check out at position 0, you know, what the character is there. Well, there isn't even a position 0. Like, this whole thing is absolutely blank and empty and you can't do anything with it. And you might think, oh, that's really stupid. Why is Visual Basic like that? Well, think of it like this. It's kind of like, say your friend was at your house or whatever, and you guys are old enough to drive cars or whatever, and you've ordered some sort of takeaway Chinese food or something like that, but you're not going to have it delivered. You're going to save money and just pick it up yourself. And so you say to your friend, you say, look, here's the keys to the car. Go out and can you go pick up the Chinese? So the guy's got the key and he goes outside and he looks in the driveway, but hey, there isn't a car there. So what the hell? I can't do anything. I can't go to the Chinese. I just can't do anything. Game over, like a program crash. And that's what's happening in the program. Like, it's going out there fully expecting to find something in there that can start substringing and pulling apart and stuff. And it goes, hey, hang on, there's nothing there. Game over. All right, so that's why you get the program crash. So we need to change our program so that the first check we do is to make sure that's not empty. All right, do the existence check. So we're going to have problems with it crashing, so we put in a check to check that it's blank. So in front of our previous code here, where we were doing all our nice, you know, ASCII number checking to check that it was an uppercase letter and stuff, if it was outside that range, it wasn't going to be good and we're going to make an error. Before we do that, we just better check to make sure the thing isn't empty, okay? So we put string customer ID. If that equals nothing, which means it's got nothing in it yet, then we need to just put out a message box. The first character must be an uppercase letter and there's an input error, and set Boolean position false. So that'll be the first thing it does, and it'll stop everything in its tracks and stop you from having that bad situation. Now, this print screen's from a piece of code where we've done a bit more work. Just change that to an end if. That's how yours should look on your screen after you've added this code in front of the other code. And previously where we had the if, just change that to an else if. So you're adding all this stuff in as new. Where you had that starting with if, make it else if, all right? And these little underscores too, we haven't mentioned about that. This line, string customer, whatever, blah, blah, or the other one, that could all go on this one line right across, but these things can end up being a little bit long and hard to read. So the way we've done it is we've just kind of used the continuation. We're saying, okay, we're doing this, but hang on, there's a bit more of what we need to do on the next line. So it continues on the next line here. All right, then we get to the then. So that's what the underscore is all about. It's nice, it kind of makes the code easier to read instead of having this giant long slab that goes forever across the page. But you'll need to make sure that's an end if. It should be an end if on your screen, and test this out and make sure it's working. So we've done 2 validation checks so far. This is the list we need for that customer ID box. So we need to first up check it's not blank, because having stuff blank can cause program crashes. That's really bad. Existence checks, that's usually the first check you do. Make sure stuff's not blank. Then if it passes that test, we can check, make sure that first character is an uppercase letter, because we need to have a customer ID start with a letter, and that's where we're up to at the moment. So let's check that out. If we run our program, if you just have nothing there and leave it completely blank and click the update button, we get this error. First character must be an uppercase letter, so it doesn't crash anymore, so that's really good, and try that out on your program. And if you put something silly in, like the number 4, because we need letters here to start off the customer ID, not numbers, if you put the number 4 there, it's going to tell you the first character must be an uppercase letter, okay? So that's all good, and that should be okay, so check that out. Now, we have got that check in. Remember that the maximum length is 11, so that's all good. They can't go typing in something that's, 25 characters long and way too big. We've got that covered by restricting this text box. Visual Basic will stop it when they hit character number 11. They can't go any further, can't add any more in. But we do need to check that they've actually put the whole 11 characters in. That is a validation check we need. So our very next check will be to check that all 11 characters have been entered, okay? So we need to check, have they put in the full customer ID? And then we can go on and do these last 2 checks to check the other part of the customer ID code. But that's our next check, checking that they've all been entered. All right, how we do that is we add this code. So this is the code we've got so far, checking for blanks, checking that it is an uppercase letter. Now we check, is the length of that string 11? So len is how you determine the length. So if length of that, what they've entered, if it's less than 11, well, that's not good. We haven't got all the stuff yet. We need to have 11 characters to have a customer ID. So tell them the customer ID is incomplete, needs to be 11 characters long, and put the text focus. So put the cursor flashing in that text box for customer ID so they know that's where the mistake is and that's where they need to fix it. If you don't understand focus, go back to our previous lesson on validation, go to the YouTube index timeline and look that up. Now this is following typical validation. So remember when we did the validation lesson, the first thing you should always check for is existence check. If something's nothing, you got to stop it there in its tracks and not let the program go any further. Because if the program continues without stuff there, like if the car isn't in the driveway, you can't drive anywhere, it's all a disaster, okay? After that, you usually check the type. So if you do have something in that text box, is it the right type of stuff? Is it a number? We wanted a number in there. If they typed letters or they typed F-I-V-E, the word 5 or something in there. So usually checking type is your next one. And then the next check we've got here is actually a range check. We're checking, this could range in size as to how many letters they type into the customer ID. We want to make sure they've typed in exactly 11 characters. No more, no less. It has to be exactly 11. So that's actually a range check. And this is pretty typical of validation. First you do existence, then you do type, then you do range. So if you're doing VC software development, you won't have to necessarily be able to write all this code on an exam or anything, but you need to know the theory part of it. Yes, if we were validating that text box, first we'd check existence, that there's something in it, it's not blank. Then we'd check the type of things in it, because, you know, this question says it had to be numbers in there. And then we check that the number is in the right range, or the number of things they've typed in, the actual length of it is in the right range. So this sort of stuff you need to know for exams. This sort of stuff you need to know for the programming assignments, okay? So let's test out whether those three things work. So we're going to be retesting that, and let's check that this 11 characters have been entered. So if it's too short, like HWU112, well, that is nowhere near 11 characters. It'll tell us customer ID is complete, needs to be 11 characters long. If they're really close, like I think you'll find that's 10 and not 11, it'll recognize that and figure out it needs to be 11 long and tell the person that. So for this one, to keep the 3 digits on the end, they'd actually have to just go into this position, I think, and insert a space just to pad it out and make it 11 long if someone's got a short name. Okay, so we've already taken care of the fact that letters have to be entered as capitals, because we've got that character casing property we're using, which is saving us some validation. Otherwise, our next step, you know, we'd have to have another step in that checklist to check that they're actually capital letters and not small letters. But thank goodness we can use that built-in function that converts automatically. So our next check is, we can now go on to check, see whether characters 2 to 8, remember they've got to be letters or spaces. So where we've got H Jacob over here, that has to be letters in those spots or spaces, okay? After that first letter's put in. So this is actually, we're doing another type check now. So you don't just do existence, type and range, 1, 2, 3, and you're done. We've done those 3 checks. Now we actually need a 4th check, and we're going back to doing type checking in this. And this is going to be kind of our most complicated check, but this is a first principles check that you could use in any language. This is a really long video. If you need a break now, just pause it, or at any time, just pause the video and come back. All right, so in this one, we're checking that the characters here, they've done the first character, character number 1's good. So we're checking that character 2, 3, 4, 5, 6, 7, and 8 are letters or spaces. Okay, that's what's allowed in these boxes. But remember, Visual Basic's a pain. It started counting at 0, not at 1. And it's not just, don't blame Visual Basic. There's a lot of languages that do this. So we actually have to check, even though it's characters 2 to 8, we have to check positions 1 to 7. So in the code, we'll be referring to substrings 1 to 7. So we'll be referring to this. Now, to check this, we could check each position one at a time. So we could say, okay, let's go this whole thing, get the substring at position 1 here. Position 1 is a number, comma for a length of 1. So let's just check this one box here and make sure it's got a letter space in it. You know, else, and you know, else if, that one's okay. Let's go on to the next one and check this one, you know, does that position. So we'd have to do a substring. Let's see, where are we now? Position 2 for a length of 1, because we can only check one box at a time. Is that a letter or a space? Else if, let's move on, substring, position 3, comma for a length of 1, because we just want to do that box. So that's going to end up some really long code. Now, if you went back right to the start of our course when we did like pseudocodes and algorithms, we talked about, we showed that BBC Learning thing, which is an awesome resource for beginners to computers, by the way. What we found was that you could use this loop. So for brushing your teeth, you could have this process where you go, yeah, I need to find that exact tooth and brush it. Then I need to find this exact tooth and brush it. But we don't do that. We kind of do iteration repeat. You just keep moving the toothbrush around, brushing all these teeth. So we need to use an iteration loop. So that's going to be a little tricky. So we're going to do pseudocode first before we write the code, all right? So this is getting a little bit tricky, but remember, just like doing layups or learning how to do a turnaround jump shot in basketball, if basketball's your thing, it's going to be hard and it's going to take practice. And the thing is, People aren't prepared to do programming practice the same way they do sports practice, and you really need to think of it as being exactly the same thing. You know, if you want to get buff in the gym, you've got to do hours and hours on the weights and take some supplements, but not roids and things, you know, just some protein and whey powder and that sort of stuff. If you want to get good at programming, you just got to do a hell of a lot of programming and like do it over and over all the time. But that's enough of the ranting. Get on to the lesson. So positions 1 to 7, they've got to be uppercase characters or spaces. So we have our pseudocode here to check it. We're going to say that positions 1 to 7, we're just assuming, yep, that they're probably going to be okay because people are reasonably smart using our application, we hope. And we're going to check first up, just make sure that that string, that they've entered in all 11 characters, because if they haven't entered in all 11 characters and you go in and do this stuff with the substrings, you're going to get a program crash if there's any blanks, if there's any nothing stuff there. So let's just make sure they've got all 11 characters there. Then we're going to just do repeats. We're going to repeat 7 times because we've got 7 of these to do. And we're doing the same thing each time. We're just going here for a length of 1 in the substring, checking out, hey, is that a letter or a space? Good, let's do the next one. Is that a letter or a space? And we're just going to go along and work out. And if any of them are wrong at all, we'll set the variable, the Boolean thing to say, false, false, something's wrong, something's wrong. But we're not going to sort of indicate, oh, it was actually this position 3 that was wrong, which, by the way, because you're looking at it on the screen, is actually the 4th character. We're not going to get that specific. We're just going to scan this whole thing, and if any of these things don't have letters or spaces, we'll just put out one message at the end. Okay? So what we do is I equals 1 to 7. So first time it goes through the loop, the value is 1 for the I. So it'll come in here and do 1, 1. So it'll go to position 1 for a length of 1. Check this box out here, make sure it's okay. If it's not okay, it's going to set the Boolean thing to false so that we can record, hey, that wasn't right. We can mark that down on our list of things that are wrong. Then we're going to go next. So then it goes to number 2. So it goes substring position I is up to number 2 now, so it goes 2, 1. So it'll go to this position here, position 2 for a length of 1 means just do that one box there. It's going to check that out. If that's okay, it'll just do nothing. If it's got something wrong with it, this indicator gets set to false. Then it gets to I equals 3. So here it'll be doing substring 3, 1 because we're up to number 3. So it goes position 3 for a length of 1, just check out that box, see what's in it. So it keeps spinning around, doing this over and over till it gets to 7. So it'll do number 1, number 2, number 3, number 4, number 5, number 6, number 7 up there. Then it'll stop. When it stops, then we get it to check whether there are any problems at all with any of these. We don't care which particular one. All 7 of them could be wrong, but maybe only 1 or 2 of them are. So this is an important thing. You might have thought, okay, well, let's tell them straight away here, as soon as we find something wrong, put out the error message. But if you do that, the trouble is that you'll get all these repeating error messages. Like if 2 or 3 of these are wrong, it's going to sort of tell them 2 or 3 times, and it's going to be annoying. So we'll just, you know, zoom through with the loop, check the whole thing, and then at the end we'll tell them something's wrong with that section of the customer ID. Characters 2 to 8, something is wrong. So anyway, that's the pseudocode. That's how it's going to work. We've got that all cleared up. Now all we need to do is code it. So with the coding, whoops, better go back there. This is how the coding works. So we've got if the length of the thing, check out that it's 11 long before we do anything. If it is, we set up our loop for I equals 1 to 7. Now we've just called it int position instead of I, because that way it's just a little bit clearer what we're talking about. We're talking about the position in that character string. So if it's between 1 and 7, from 1 to 7, we keep going through and checking out, you know, do we have uppercase letters, but it'd be okay to have a space as well. So space is all right as well. So we're checking for uppercase letters or space. If that's, actually, no, sorry. What we're doing is we're checking if it's outside the range. If it's less than 65 or greater than 90, that means it's not in the uppercase letter range. And if it's not equal to a space. So in other words, we're checking if it's bad. So here we're just checking if it's outside the 65 to 90 range, which is where the uppercase letters are in the ASCII code table, Or if it's not equal to a space, which is ASCII number 32, that's bad. So we're saying there's something wrong there. Positions 1 to 7, set it to false. And then we spin round and do all 7 positions. Then after we've done the 7, if the thing's 11 long and positions 1 to 7 okay, didn't come up good, it came up false, then we need to output this message box. So we just output one message box. Characters to date must be letters or spaces. It's up to them to kind of look at it and figure out which characters are the wrong ones. So some test results for checking that. If they type in HSIM5 PSO, so that obviously should have been an S, but somehow it's turned out a 5. That's not a letter. This has to be letters or spaces in positions from here. That's position 0, remember, so this is 1, 2, 3, 4, 5, 6, 7. These all need to be letters or spaces. We've got a number in there, game over. Characters to date must be letters or spaces. So hopefully they can look in there and go, oh yeah, we're looking in this part here, that's 2 to 8 for characters. And yeah, oh, we got a number in the middle there. Oh, that's what's wrong, and they can backspace and fix that. And if you do PJ Passy, 1, 2, 3, 4, the thing is we shouldn't have had that 1 there. That's supposed to be another letter. We're only supposed to have 3 digits on the end. We're not supposed to have 4. So something's wrong there. This should have been a letter or a space there. So it'll pick that up and tell us characters to date need to be letters or spaces, so the person can check that out. All right, so now we're just down to the final step, checking the final 3 characters are 3 digits. And for the ASCII table, the digits 0 to 9, just numbers between 48 and 57. Okay, that's how that works. If it's converted, if you take whatever they've typed in, like here they've got a 3 on the end of that. If you take that, get its ASCII value, which would be 51, check out what they've typed in and stuff. Hey, yeah, that's one of the numbers, that's good. So you don't have to hard code with 10 different if-elses. You know, if it's 0, else if it's 1, else if it's 2, else if it's 3. You can just say if it's greater than 48 and it's less than or equal to 57, greater than or equal to 48 and less than or equal to 57. One line of VB code instead of 10. That's why we do it with these ASCII codes, right? Because you're thinking, oh, why can't we just say the letters? Well, you can if you want to do if, else if, else if, else if. Anyone reading your program is going to think, hey, that guy's an idiot. Doesn't he know about ASCII codes? You know, that's how it is. Like if you're going to play basketball, but you can't do a layup and you can't kind of shoot long shots or something, you know, you're not going to be a basketballer. So that's kind of how it works. Right, so that's the code that we put in, and put that code in, check your program out, pause the video as you need to, and that'll be the last check done. So what'll happen is that if they put 2A3 onto the end, well, they're supposed to have 3 numbers, not the letter A as one of those last 3 things. So our checking's working on that, and we're getting a good error message. And our checking's working on that they've put a letter there instead of putting a number. We needed 3 numbers on the end, not a letter. So that's all working, and told them to fix that up. And now we just need one more section of coding, and then this whole thing with customer ID, gee, it's been a long journey, that's finished, and we can give them a success message. All right, so the final section of code is just going to be that we're going to have at the bottom of our sort of whole validation subroutine we've been adding to for our customer ID, checking out if it's all right. We're just going to say, okay, if position 0 was okay, if the thing was 11 long, if 1 to 7 checked out okay, that they were letters or spaces, and if 8 to 10, those last 3 positions are numbers, if all of that's good, well, then we're just going to say update successful, yay, customer ID updated, and just let them know that clicking that update button kind of worked okay because all of the data was all right. We're not actually going to update it and write it to a file. That's later in our course, we do stuff like that. But we'll just give them a success message so they know something happened and something's really good. So if they put in H Simpson 1, 2, 3, that is good data. We're starting off with an uppercase letter. Positions 1 to 7 here, or character positions 2 to 8, they are all letters or spaces. Beautiful. And we've got the 3 numbers on the end, and the thing's exactly 11 characters long. Kicking goals, all right? So customer ID updated, update successful. If they've got a smaller name like Jay Zoo here, they can just put in 3 letters, fill that up with 5 spaces, so that thing's 8 long, and then 3 numbers on the end, 101, 101, so that's going to be 11 long altogether. We just got a mixture of letters and spaces here to make up the first 8, then 3 on the end. That's all good. We give them the success update successful message. Okay, so that was like a really long kind of thing. And you're thinking, wow, why was that so much work to do that? Well, using these ASCII codes and the for next loop, this is a first principles thing that you could easily take across now to Python or to other languages and do the same sort of stuff, all right? You might have to change the code a little bit, but it's kind of like, I don't know if you've, apparently people that speak Italian, like when I was in South America, because they spoke Italian, they could understand Spanish really easily straight away, whereas I had no idea what the people were saying. And apparently, like, you know, if you do this first principles stuff, it's going to be like that. You know how to do it in Visual Basic with for loops and ASCII codes, which was really a long, hard way of doing it. Because, you know, some people that know Visual Basic will be going, oh, why did you do it that way? You could just use regex pattern matching and it'd be so much easier, so much less lines of code. We just use Visual Basic regular expressions, you know. And that's true, and that's what we're going to look at next. But this is first principles. This will work in any programming language. And the other thing is, on an exam question, if you're doing like software development here in Melbourne, Victoria, Australia, they won't have code written, but they could have pseudocode written for doing some validating on the exam. And the pseudocode will be done this old school way with for next loops and maybe ASCII code checking, and they might give you an ASCII code table to look at on the exam. All right, they're not going to have Visual Basic regular expressions, the easy way of doing it. You can do it that way on your project, but this is kind of first principle stuff you need to know for exams and other languages. We just talked about first and last name validation before we get onto the regular expressions, the third and final part of our lesson. Now, just be careful validating last names. A typical thing for beginners is they think, oh, well, someone's last name is probably just like mine, Passy, so I just need a big P and then some little letters after that. So yeah, I'll just write one of those little ASCII code loops that we just learned, and I'll make sure the first thing's uppercase P, an uppercase letter, any of those uppercase ASCII values, and then they've just got little letters after that, and it's all good. But some people have really long names like Kate Watson Smythe, this English blogger here. That needs to be longer with a hyphen in it, so you've got to make sure you allow for dashes or minus signs or hyphens in the middle of people's names. And then some people's names, take a deep breath before you say this one. Julia Scarlett Elizabeth Lewis hyphen Dreyfus. Whew. I think that was the name. When I Googled for the longest name of a Hollywood actress, I think that was it, and that's her. She was in Seinfeld, if you guys aren't old enough to remember that, but that was a great funny TV show, and quite a few other movies. So people get very upset if you spell their names incorrectly, or if they couldn't type their name in, or someone couldn't put their name in a form. So yeah, make sure when you're doing uppercase letters, you can do it just like we did that customer ID, but you'll need to make sure you allow for uppercase. Just force them to put the name in uppercase. Don't let them use little letters. Just force it to all be uppercase. And make sure you got hyphens and spaces allowed as well. All right, finally, our final part of the lesson. Regex pattern matching. All right, now what's that all about? So this is great for fields like phone numbers, and you could actually have done customer ID like this as well, rather than using basic raw build it with your hands first principles. That's what real programmers do. But if you want to use regex, look, use it for some things because it's great. So what we're going to do here is on that program we're just working on that you've tested and it's all working great for customer ID code, and congratulations to you for going through all that hard work and learning how to do a basketball layup. We're going to put in another character field here now, mobile phone with a text box, and that needs to be called, we haven't got the name of it there. Yes, we have. No, we haven't yet. That's going to be called text phone number, TXT phone number. All right. So Visual Basic has this built-in function called regular expressions, or regex that you import at the very start of the program. And so this is how we define the phone number we want to type in. So the regex pattern for that, to get 2 numbers, then a minus sign, then 4 more numbers, then a minus sign, dash, then 4 more numbers. How you can get them to type in that pattern, or how you can check they've typed in that pattern, is using this /d curly brackets 2. How does all that stuff work? And you might look at that and go, no, I did the layout, but that's it. Basketball's too hard, programming's too hard, I'm quitting. Don't do that, all right? It's not that hard. What the D means is, the D means that it's a digit character, so it can be between 0 and 9 inclusive. Okay, so that's what that means. That's what has to go in that first position. 2 means that we've actually got 2 of these Ds. So you could have put DD, but they've just put curly braces 2 to say these 2 positions here, the first 2 in that phone number, need to be digits. So it needs to be something like 04 in Australia for a mobile phone number. Other things if you're somewhere else. If you're in a different country and use 3 digits, just change this to a 3 in here. Right, now this red minus sign here, that means we've got to have a hyphen symbol in there. All right, so we use these slash things to just break between the sections. So the first section is we're having a couple of numbers and a minus sign, and then we put a backslash sign to tell it that that section's finished. Then we need 4 of these Ds, okay, 4 digits entered, then another minus sign, then just break it. That's that section done. Then we need 4 more digits on the end. So that's what that's saying. And you'd have to memorize that and know how to construct it. You just Google it or get it off Stack Overflow like I did. And yeah, then you've got it there to use in your program, and you can reformat it easily for different countries and different phone numbers. So to get this going, we need to actually import regular expressions. It's a special function library you bring into Visual Basic. So you need to type that in just like it is there up the top of your program. Now, when you do that, Visual Basic's going to kind of gray it all out and give you this message if you hover next to it or something saying, oh, why are you putting that in? That's not needed. Well, it doesn't seem to be needed yet because we haven't actually done any regex programming, but later on it will be needed. So just ignore what Visual Basic is saying there and ignore how it's graded out and just type that in, get that typed in exactly that you're importing that to use it. And that has to go above form 1. A common mistake is to type it down and use the first line in your program, but no, it has to actually be up above where public class form 1 is, so make sure you do that too. Next thing is where we've got that stuff about for customer ID that had to be a maximum length of 11. Set this TXT phone number, that's the name of that text box, set that up so that its maximum length is 12 because we need 10 digits for the mobile phone number and we need 2 more to get those 2 dashes in there, so 12 altogether. And then where we've got our current update button processing, remember we built a separate subroutine to do customer ID, and so we just had the 1 line of code here because we were modularizing. So we're going to do the same thing. We're just going to have 1 line of code here called validate _ phone number double brackets, and we're going to take that and put that underneath as a whole separate subroutine, okay, just to modularize and simplify. So this code here for customer ID is already super complicated enough. So we don't want to be adding a whole bunch of more code into it for phone number and making it longer than it is already. So we're just going to do all of this in a separate sub procedure or subroutine. It's like a book. They divide a book up into chapters. All right. So once they've done the chapter on this, like, I don't know if it was a maths book, should I say that? People hate maths. But if it's a maths book, if they've done the chapter on fractions and decimals, right, and now they're going to do stuff about triangles and geometry, you just don't keep adding that into the fractions and decimals chapter. You put like end of chapter revision, then you have a new chapter that's all about triangles and geometry and stuff, right? So we're just doing that in our program, like chapters in a book. We've done the chapter on customer ID, know how to do that. Now we're doing one on phone number and learning about regex. Okay, now for the regex coding, for that subroutine validate phone number brackets, you put dimension valid phone format. Okay, so that's just a variable we're making up. We're saying this is what the valid phone format should look like. You could call it valid phone number, valid phone regex pattern, valid phone pattern. I've just called it valid phone format. This is what a phone number is supposed to look like. As new regular expression, that's what we imported that thing in for, regex. Then we put in that special kind of masking code. If you've done our databases access course, this might be a bit more kind of familiar to you because it's a lot like custom masking. But anyway, you just put in that pattern. We want, you know, 2 digits, a dash, 4 more digits, a dash, then we want 4 digits on the end. So that's the regex pattern we're using, that our custom pattern we built with our bare hands as programmers, because that's what we do. If that valid phone format, if this regex pattern matches up, if that matches up with what's in the text box for the text they've entered, that's good. Okay, so we can say update successful, mobile phone updated. But if what we've got typed into that text box doesn't match this pattern, maybe they just put the number in and didn't put the dash, hyphen, minus sign things in here when they type theirs in. If that doesn't match up, it'll go to the else and put out a message box saying, hey, enter a phone number like 04 dash, then put some numbers, dash, then put the rest of the numbers, because what you've got now is an input error. Okay, so that works like that. When you try it out, like if someone does 04 dash 222, but they forget to put the dash here before the 555, it's going to tell that message, error message, which we set up. All right, so that's going to fix that up so that we get nicely formatted, easy to read phone numbers in the text boxes. And if they do it all 100% correct, 04 dash 4 digits dash 4 more digits, matches up exactly with that custom regex pattern that's set up, the text that's in that text box, well, then we just get the update successful message there, all right? So that's regex pattern numbering, a really quick way to validate phone numbers. And yeah, if you need to do regex at any time, come back to this video, look at the timeline index, or if you've got the PDF document, just scroll through that till you find the stuff about phone numbers. Now, on the program where we've got up to now, it kind of does, it's a bit awkward. It does like update successful on this, and then it goes through all this and does update successful on that. It'd be much nicer to just have one sort of update successful at the end when they've entered both of them. So you could fiddle around with global variables and do some stuff to change that and tidy it up a bit. It's a bit clunky now. Like if you stop now, check this regex coding you've done, make sure it works and everything, and you'll find that the message boxes typing up are a bit clunky, and you could tidy all that up if you want to. Okay, the final regex we're going to do is for email addresses. So when you've got an email address, it's got to kind of be something at something, then dot something on the end of it. Now the pattern, whoa, don't pass out and go for the smelling salts or heart pills, because this is super complicated. Now, no way I figured that out, or I'm going to read pages of regular expressions documentation and write this by hand. So when I say programmers build stuff with their bare hands, we don't kind of go down to the state of kind of building Michelangelo things, all right? So how can I explain this? Like, maybe with your bare hands, you might kind of, if you've got a motorcycle, you might work on your motorcycle and kind of tighten the chain and change the oil, and certain parts you could pull apart and fix, or go and get bits and replace them and stuff like that. But you're not going to kind of like get all the parts and build a motorcycle yourself, like the whole thing, unless you're really into it. So we're not going to do this, man. We're just going to go to Stack Overflow, find one that everyone says, hey, yeah, thanks for that. That's a good one for emails. And that's the one we've got there. And so we add a text box onto our form here now where people can put email address in, txt email address. Just make sure the character casing on that, like if you've done kind of Control-C, Control-V using this previous one here, remember that had character casing turned on to upper, so that property will actually be turned on here. So just make sure character casing's normal on that in the properties, and make sure the length of that is pretty long. So if you've copied this one, it'll only be 12 long maybe, because you set that in the properties. You need about 200 for an email address. They could be insanely long, so just leave it nice and big at 200. So get those two things set up on that text box as well. It needs to be called txt email address. And then it's pretty much the same as we just did for the phone number. You just dim, this is the valid email format. It's this big long thing here that we got off Stack Overflow, and that's our new regex. And so is what they typed into that email text box, does that match up with what we've defined here in this previous line as our valid email format? And I've got our phone number is valid. Oh, well, that should say our email address is valid, that comment in the code. All right, I'll have to go and fix that in the code. I'll have to remember to do that. Otherwise, you give the error message. Right, so we tested this code, and because email addresses, some end in .com, but in Australia, like a lot of ours are in .com.au or .edu.au, and if you're in the UK, it would be .co.uk for a lot of your addresses. So look, when we test this out with all sorts of different things, we do a .co.uk, that's all good, it likes that as an address. If here they've left out the @ sign, that's all good. It picks that up and gives them the error message. If here they've put you might not be able to read that, but they've actually put a comma in instead of a dot, which is a pretty common error for email addresses. They just put comma there instead of a dot. It picks that up and tells you there's an error. Here, everything's good. They've put in a gmail.com.au address with the @ sign, so that's all good. The only problem was this one we found in our testing. You could put 2 @ signs in. All right, now this is where you kind of make a decision. You think, well, would anyone be dumb enough, to put 2 @ symbols in an email address? Probably not. So look, we're not going to go and add any more to our validation. But if you're a real stickler, if you're really fussy about detail, yes, we could check that there is one @ character in there. Going back to our build it with your bare hands 4 next loops, we can now just add one more check before we give the message that everything's okay. We could just quickly use a 4 next loop, find out the length of the email address, and then say for I equals 0 to the length of that -1, go through there and check, count how many @ symbols there are. So if we hit an @ symbol, we set our counter. If we hit another @ center, we go counter +1. And if at the end of that loop, for I equals 0 to length -1, next, if at the end of that loop, that counter is bigger than 1, we can say error email address must only have 1 @ sign in it. Okay, so we could put in a check for that. It'd be a little bit of coding work. Do we really need to? I don't think so. I don't think anyone's going to be stupid enough to put 2 @ signs in. If they are that stupid, they probably can't even spell their name properly, so they'd get the email address wrong anyway. But if you want some extra practice and a challenge, put that in. Put in a counter to count that only 1 @ symbol is in the email address. All right, now Visual Basic and C# have both got this regular expressions thing, which is so easy to set up once you kind of understand it, and just get the thing you need off Stack Overflow. And so good. Now this program here, this is done in C#, which is Microsoft's development language. So Visual Basics, you can kind of develop prototypes in it, but if you want to write real programs, if you went to work for Microsoft, you'd have to learn C#. But regular expressions work in that as well. And this is a really cool one. You can use regular expressions to locate and replace things. So we were just locating something and checking out that what was in that location was all right. You can also replace what's in that location. So if you've got people's names with Mr., Mrs. and Ms. on them or whatever, and you just want to take those names off, just so you've got Henry, Hunt, Sarah, Samuels here, and that just to put some stickers on some name tags or something like that. You can do that, and you just go along with a regex and replace, the pattern so that you remove these kind of Mr., Mrs., Miss, and Ms. off the front of the string. So you can just get rid of them and just have the name part instead. So that's a handy thing to know. So that's great if you're in Visual Basic or C# in a Microsoft environment, but what if you're working for Apple and doing Apple stuff because they use their own special version of C? What if you're developing web stuff and using Python or C++ or something else? Well, you see, with the 4 next loop method we taught you with the ASCII codes, that's something you use in all of those languages. So that's a first principles thing. That's great. When you get to certain languages, there will be nice little functions like regex, and when you're using that language, use them because they're nice, but always remember your first principles ones, because that's what learning programming is all about, learning those bare bones tools that you can use pretty much in any language. Now, just before I go on to there, I might have a bit of a rant. Why do we have all these different languages anyway? Well, it's a bit like the world. Why doesn't everyone just speak English? You know, I went to South America and everyone was speaking Spanish and virtually no one spoke English. All right, so, well, they just don't all speak English. So there isn't one standard language. Now with programming, there isn't a standard language either, and that's just the way it is. It's the same with cooking. Like if you want to become a chef, you might love cooking Thai food and you learn how to make curry paste and learn about lime juice and you kind of, what's that special sugar they use, that special super sweet brown sugar, palm sugar. Learn all the spices and combinations and stuff, and you're a fabulous Thai chef. But you know, that's great for Thai cooking, but if you're a chef, you probably have to learn how to do French cooking with white wine sauces and stuff like this. You have to learn how to do Italian cooking, which is a whole separate thing of herbs, Indian cooking where they use the tandoor clay oven and different curry pastes and herbs. So you're not just going to be doing one sort of cooking, okay? You're going to have to learn a few different things, and that's just the way it is. Like if you want to be a chef, it's unlikely you can just learn one type of cooking, like just learn Thai cooking and just be a Thai chef. Maybe you can if your dad owns a Thai restaurant or something like that already. Same with programming. You're not just going to learn one language and just do all your work in that. You will have to know some others, and that's just the way it is. If you want to travel around the world to different countries, you have to know how to speak a little bit of their language, all right? If you want to be a chef, you got to know how to do all this different sorts of cooking. If you want to be a programmer, you've got to learn a whole bunch of different languages. And sorry, my friends, ladies and gentlemen, girls and boys, that's just the way it is. The resources for this super long video, because goodness knows how long it is, an hour and a half. I think this is going to be a Passy record for a video. Lucky you got that timeline index to do sections as you need to. All right, the resources for this, click the link in the video description and you can get all of that. You know, this is a pay-for lesson, I think, because it's a really long one. Remember, the prices, guys, are like less than $2 American for individual. If you're a teacher and want to get this for your class, because this is pretty hard to explain to a class, took me an hour and a half on a video to explain it. Yeah, just grab the PDF and the Word doc to use for your class, get a site license, because that's like less than $4 US, about $5 Australian, and then you'll be set. So the full programming course is on our website. So if you go to the Passy's World of ICT, passyworldofict.com, at that direct link if you want to, /programming, that'll take you into the programming course, and you can go through that and find particular lessons and check out their videos, check out their resources, all that sort of thing. So anyway, sorry this was such a long lesson. I've probably spoken too much as usual, but look, hopefully for beginners it's been helpful. This whole thing I'm doing is for complete beginners because, look, I've been teaching for 10 years. I've seen kids struggling and almost in tears, crying and wanting to give up. But look, you've just got to just hang in there and just keep doing it till it's okay. It's like getting really good at a particular sport. There's certain skills and things which first time you try them, you think, how am I ever going to do that? Like I remember in karate, roundhouse kicks after you've just been doing simple punches and simple kicks were so hard, but you know, you just keep doing it, and then, oh wow, it suddenly all makes so much sense. And do the same in your programming. We're putting out a video every week, so subscribe to our channel so that you don't miss any of our updates. And if you find any parts of this video helpful, click the like button. All right, that's it for this week's video, and we'll see you in the next lesson.